this question, we're given a graph. I can see that this line that is labeled g of x is the red line here. And then we have a parabola that is labeled with f of x. And we can see that curve here. And in this question, we want to evaluate some compositions using the graph. We have f composed with g of 1, g composed with f of 1, g composed with g of 0, f composed with g of f of 2, g composed with f composed with g of 0. So we're going to use the graph to answer these questions, but first let's focus in on this operation composition. Composition is the operation where we substitute one function inside of another function. F, listed first, is the outside function, and G, listed second, is the inside function. So we want to substitute G inside of F, and this value here is going to get substituted inside of G. So if we go one step at a time, looking inside the parentheses, we want to find G of 1. G of 1 indicates that x equals 1. So on the graph, I'm going to find where x equals 1, and x equals 1 along this line here. These are all the ordered pairs where x equals 1. I'm interested in the one that falls on the graph of G. So I'm interested in this point here. That point has a y value of 2. So G of 1 equals 2. And now my symbols have simplified and I have f of 2. In f of 2, that indicates that x is equal to 2. X equals to 2 along this vertical line, and I'm interested in where f is at 2. So that's this point right here. So that vertical line that has x equals 2 crosses the graph of f at this spot, and that has a y value of 0. So f of 2 is 0. So we found that f composed with g of 1 is 0. Let's try the next one. I'm going to erase some of these markings. On the next one, we also have composition. So remember, composition is substituting one function inside of another function. So that gives g of f of 1. G is the outside function, f is the inside function. Let's start with f of 1. F of 1 indicates that x equals 1. So here's the line where x equals 1. I want to find f of 1. So I'm looking at the spot where the line, the vertical line, crosses the graph of f. And that has a y value of -1. So f of 1 is -1. The symbols that I have left say g of -1. But -1 is an x value. I'm looking on the graph, and this vertical line has x values of -1. If I look where that vertical line crosses the graph of g, that's at this spot, and it has a y value of -2. So g of -1 is -2. Let's take a look at the next one. The next one says g of 0. Composition is substituting one function inside of another function. G is on the inside and the outside this time. G is on the outside, G is on the inside. We want to find g of 0. This vertical line is all of the ordered pairs that have an x-coordinate of 0. I'm interested where that vertical line crosses the graph of g, and that's right here. And that is a y value of 0. So g of 0 is 0. And we have g of 0 again, that will also be 0. Let's take a look at the next one. The next one is a little bit different because we have three functions. We have f composed with g composed with f of 2. And when we have more than two functions, we just keep embedding them inside of each other. So f will be the one on the outside. Then inside of that will be g. Then inside of that will be f. And inside of that will be 2. So we'll start by finding f of 2. X equals 2 is this vertical line here. Every ordered pair on that line has an x-coordinate of 2. We're interested in this point here that crosses the graph of f. That y-coordinate will be 0. That's f of g of 0. F of 2 is 0. So now we need to find g of 0. I've already drawn this vertical line here with an x value of 0. That vertical line crosses the graph of g in this spot here, and that has a y-coordinate of 0. The g of 0 is 0. Finally, I need to find f of 0. I've already got the vertical line at x equals 0, and this spot right here is where the graph crosses, where the vertical line crosses the graph of f, and that is at the y value of -4. F of 0 is -4. We've got our last one here. Let me erase all these markings. G of f of g of 0. So g is on the outside with f on the inside, g on the inside of that, and 0 all the way inside. So we're going to start with g of 0. Along this vertical line, these are all the points on the graph that have an x-coordinate of 0. We're interested in this point here because that's the point that crosses the graph of g. G of 0 is 0 because the y value at that point is 0. So now we have g of f of 0. Now we're going to find f of 0. We've already got the vertical line x equals 0. We're interested in this point here where that vertical line crosses f of x. The y-coordinate there is -4. F of 0 is -4. Finally, we'll find g of -4. This is the vertical line, x equals -4. We're interested in this point where the vertical line crosses the graph of g. That has a y-coordinate of -8. G of -4 is -8. In this question, we want to find the domains of f composed with g of x and g composed with f of x. F of x is equal to x squared minus 10, and g of x is equal to 1 over x plus 1. I've got some notes that I provide my students to indicate how to find the domain of f composed with g and g composed with f. I'm going to go over these steps, but it's really helpful to know the domain of these individual functions before we try to find the domain of these composed functions. So we're going to start with that and then come back and take a look at these instructions. So first, let's find the domain of f, which is x squared minus 10. As I look at x squared minus 10, this is what we call a polynomial function. And I know it's a polynomial function because it doesn't have any variables in the denominator, under radicals, inside absolute values. And then if I focus in on the power on x, it's one of the nice numbers. What I mean by nice numbers are whole numbers, 0, 1, 2, 3, 4, 5. If that power was fractional or decimal or negative, then it wouldn't be a polynomial. But because it's one of those whole numbers, 0, 1, 2, 3, 4, so on, it makes this a polynomial. Now, what's nice about polynomial functions is that there's no restriction on the domain. The domain of this function has no restrictions, meaning that every real number can be substituted into the function and we will get a value of y. So the domain is negative infinity to infinity, all real numbers. Then let's look at g of x. G of x is 1 over x plus 1. This is called a rational function. It's a rational function because it has a variable in the denominator. And rational functions could possibly have restrictions. Because we have a fraction and a variable in the denominator, we are concerned about dividing by 0. Dividing by 0 is something that is undefined in mathematics. So we want to avoid that. I'm going to figure out what the restriction is for this function by taking the denominator and setting it equal to that value that's not allowed. Division by 0 is undefined, so we set that denominator equal to 0 and solve. I'm going to subtract 1, and that gives me x equals negative 1. That's my restricted value. And the domain of g will be all real numbers except for negative 1. Negative infinity to negative 1, union with negative 1 to infinity. So now we found the domain of these individual functions, and we want to find the domain of these composed functions. So let's start with f composed with g of x. Now when we're finding the domain of f composed with g, we're going to start with the domain of g. We're starting with the function that's on the inside, the one that's listed second. So our starting domain, we're going to start with negative infinity to negative 1, union with negative 1 to infinity. That's the domain of g. So we already have a restriction. We already have a restriction that x cannot equal negative 1 because of g. And then in the second part, we need to adjust by excluding any values of x where g of x is not in the domain of f. So what that means is we need to come up with some extra restrictions, and we don't have any because the domain of f doesn't have any restrictions. But because this domain of f doesn't have any restrictions. Remember earlier, it didn't have any restrictions. That means that we're not going to find any new values. So that domain that we started out with is the domain of this function. The domain of f composed with g of x is negative infinity to negative 1, union with negative 1 to infinity. Let's take a look at the other one, g composed with f of x. When we're finding the domain of g composed with f, we do it in the same way. We're going to start with the domain of the inside function, whichever function is listed second. So we're going to start with the domain of f. And that was all real numbers. We have no restrictions. And then we're going to adjust. We're going to adjust by excluding any values of x where f of x is not in the domain of, and that's a typo right there. That should be g. So we're going to adjust by excluding any values of x where f of x is not in the domain of g. So remember that we only had one value that is not in the domain of g, and that was negative 1. So we want to find where f of x is equal to that value. So we're going to solve the equation f of x equals negative 1. That's x squared minus 10 equals negative 1. I can add 10 to both sides to get x squared equals 9. I can square root both sides to get x equals plus or minus 3. And plus and minus 3 are my additional values that I need to exclude. So I want to exclude negative and positive 3 from the domain that we started with. So we had a domain of all real numbers. That was the whole number line. Now we're going to take negative 3 and 3 and get rid of those two values. And we're going to be able to write this domain as negative infinity to negative 3, union with negative 3 to 3, union with 3 to infinity. So this is the domain of G composed with F. Thank you for checking out my videos. Have a great day.